today. And we heard earlier about a lot of questions from the audience talking with Don Topscott about, what about the future? What about our kids? I can take care of me, but what about our kids? What are they going to use technology and innovation for? How is it going to affect them? How is it going to live in their world? Well, we thought, what better way to address that specifically than to have one of the next generation up here? Our next presenter is a wonderkin of sorts. He's 13 years old. He just returned recently for the Rome Maker Faire, and he is here to share some insights about 3D technology and technology in general and how he gets a look at it, and he wants to share his story with you. Please put your hands together for Schuyler St. Legend. Schuyler!
Great intro.
Well, you are welcome.
First off, I'd like to thank Charles Schwab for putting together this great impact event. As most of you may know from your experience, when the CD came out about 25-ish, before it was born, it was a revolutionary, disruptive technology. It meant for the music industry that you can have more audio in a higher quality in a smaller area. But then something revolutionary happened. The personal music player came out. And this led to people figuring out how to rip CDs. And when this happened, websites like Napster were created. It meant that people can share music instead of buy it. And the music industry did not like this at all. When the film industry made the transition from analog to digital with VHS to DVDs, they implemented what is called digital rights management, or DRM. What DRM is, it's where you control either how someone can view something or what they can do with that something. In this case, that something is the videos. And for it, what they did is they implemented encryption, so you can only play it on authorized DVD players. But there's a problem with this. The encryption wasn't set up that well. So the 16-year-old kid from Norway, using what he learned online from internet relay chat to ask people for help, and also just reading websites, he was able to figure out how to break the encryption. This meant that you could also download DVDs to your computer and share them. These two examples are classic examples of a large, profit-driven corporation versus the open source community who believes information should be free and available to everyone. Now I'm going to talk to you about patents. The 3D printing industry has long been controlled by patents. Even though 3D printing was created in 1984, it's only really become affordable in the last 5 or so years. That's because until recently, 3D printing was dominated by patents, which meant that the cheapest 3D printers cost thousands of dollars. But what happened was when the patents expired, open source groups were created. One of those groups is the RepRap Foundation. The RepRap, or Replicating Rapid Prototyper, is a low-cost, affordable 3D printer that anyone can download the design for and build themselves. It costs about $500 to $1,000. What's interesting is when the patents expire, there is sort of a patent cliff, like I forget his name. My memory's not sometimes as flogged like other people's too. But for it, he mentioned the patent cliff. This happened with 3D printing. What happened is companies realized they were losing their market share when these open source communities created low-cost, affordable 3D printers. So what they did is they created their own commercial 3D printers. One of a low-cost version. One of these you can see in the SkyMall catalog. You may have seen this on your way here. It's the Cube 3D printer. For about $1,300, you can buy your very own 3D printer from SkyMall. It can't get more mainstream than that. Now let's take a step back and look at how 3D printing works. The way a 3D printer works is you first start with your digital model. That model can either be a 3D model you download online, or it can be something you make yourself, either by 3D scanning an object, or you design it using software like Autodesk 123D Make, or professional tools like SolidWorks and Autodesk Inventor. You then load that model into a software that will slice the model into layers. Those layers are what the 3D printer will then use to build the object. It builds it up layer by layer. And when it's finished, you have your completed object. With 3D printing, you can make many things. You can make things that would be too intricate to build any other way, like this ball that's a ball with a ball within a ball. Or you can build this really cool gear thing that was actually printed in one piece and came out of the printer like this. Now this was printed on a more expensive printer made by Z-Corp, and it actually has the ability to print in multiple colors in one print, but the more you pay, the more you get. Now 3D printing has all sorts of applications. First one I want to talk to you about is the use of it in a commercial product. 3D printing can be used as a service. This is where if I don't want to have to own a 3D printer, or it's too prohibitive for whatever reason, I can go online to a company's website and I upload my model. From there, they will then print it and mail it to me. This is great for two things. One, it makes it easy for me to get 3D printing technology without having to have a 3D printer. And two, it also means that I can have accessibility to higher-end 3D printers, like 3D printers that can print in metal. These companies like Shapeways and Pinocchio also have the ability to sell your designs. You as a designer can go to their website, upload your model, and then other people can buy that 3D printed thing from that website. It means that you yourself, as a designer, don't have to have your own store or 3D printer. You say, hey, you sell it for me and I get some of the money. But 3D printing doesn't have to be used where you do the design. Other people can do that too. These are the Makeys. They're a doll that you can make exactly the way you want it. You go online to the Makey website. You then will go and choose exactly what you want your Makey doll to look like. You can adjust all sorts of things on it. When you're done with that, you can then order the doll. They will 3D print it and mail it to you. So now you have your own doll that reflects you or whatever you want to see in a doll. 3D printing doesn't only have applications for toys like this though. It also has applications for real-world problems. This world has many problems: transportation, pollution, clean drinking water, climate change. 3D printing can be used to solve some of those problems. This is the Irby. It's a 3D printed car. What they did is they designed a car that uses a 5-horsepower engine and gets about 280 miles per gallon. This car, they believe, can go from San Francisco to New York with 10 gallons of gas. I believe it will revolutionize the way our transportation works. It means that you don't need to go to the gas station every day. You can go there maybe once a week or even once a month, depending on how much you drive. But that's not the only use for 3D printing. There's also the 3D printed handgun, which I believe many of you have heard about in the media. Now, while I don't think that it's worth all the hype it's deserved, I do think it's something we need to be careful with. It's a gun, like any other gun, we should be careful, but it doesn't mean that. I don't think it's going to change the way guns are made. But the military is interested in 3D printing. They're interested in it in sending it to the front line. Their goal is to have whenever they need a replacement part, instead of needing to order that part and wait for it to arrive, they built the Expeditionary Lab. What this is it's a shipping container that has CNC mills, 3D printers, and many other rapid prototyping technologies that makes it very easy for them to fabricate their own replacement parts. But the military aren't the only people getting interested in 3D printing. NASA is working with Made in Space to send a 3D printer to the International Space Station. This will mean that instead of when they say, Houston, we have a problem, they need to wait a month for another rocket to come up with a replacement part, they say, okay, here's the design, now can you print it? This means that 3D printing can be used for making replacement parts. It can also be used for the medical applications. When an amputee gets a prosthetic, it can be very hard to get a good fit with the socket on the stump. So with 3D printing, you can 3D scan that prosthetic, their stump. Then you can make a custom socket that fits their stump perfectly. But 3D printing has many other medical applications. This kid, Lee, was born without any fingers on his right hand. So they were able to 3D print him a prosthetic hand that fits him perfectly and does everything that he needs. Another cool thing about it is that as he grows, his parents won't need to spend thousands of dollars on a new prosthetic hand. They can just get him a larger one that's 3D printed and it will still fit him. So it reduces the cost of prosthetics and also makes them more accessible. The Phoenix Children's Hospital also uses 3D printing. Before they operate on an infant, they will take a CT scan of that infant's heart, and they will send it to the Arizona State University Biomedical Engineering Lab. There, we will take that CT scan and turn it into a 3D model and color code it. Then we'll send it back to them. So not only can the surgeons see the patient's heart, they can actually hold it and understand what they need to do. And because it's color-coded, it makes it much easier to understand. For example, on this one, the green stuff is what they need to remove. But 3D printing isn't limited to just plastic. You can print whole organs with 3D printing. This surgeon, Anthony Atala, was able to 3D print a human kidney using real human cells. This meant that what this means is that instead of being on a waiting list for a transplant, you can very easily go and get a kidney 3D printed, or hopefully in the future, whatever organ you need, a heart. And then you can have your own, and it's made from your own cells too, so there aren't any issues with rejection. This will change the way medical transplants are performed. I've been talking a lot about 3D printing. Now I want to talk about some other really cool technologies. Now I'm going to talk about open source electronics. This is the Arduino. It's a low-cost, open-source hardware, open-source software electronics prototyping board. It was created because at a university in Italy, they couldn't afford the existing solutions on the market, and they were also too expensive and too limited. So what they did is they created the Arduino. It's a very cheap board that costs about $30-ish and means that anyone, not a large corporation, an individual can create their own electronics project. But the coolest part about the Arduino is the shields. With the shields, you can add on additional functionality just by plugging in the module. And they also come with software functionality that makes it very easy to program it. For example, this shield gives you extra input-output capability. With shields, it means you don't have to design something that's already been designed. You can easily go and buy a shield that will then add whatever functionality you want to your Arduino. For example, you can get a cellular shield and connect your Arduino to a cellular network. This means that all sorts of new machine-to-machine and Internet of Things capabilities are opened up because you don't need large corporations. An individual like me or someone else, or one of you even, can build your own Internet of Things or machine-to-machine device. But these electronics I showed how are cool, but there are also other applications. These are the robo-roach. Backyard Brains created this cockroach that you can remote control. It has a circuit board, and that will connect to the cockroach's antenna. Will then send electrical signals to help guide the cockroach where to go. You connect it to your phone over Bluetooth, And with that, you can then go and use it to go scare a coworker who asks you too many questions. But that's not Backyard Brains' only hope of what they can do with these electronics. They want to make neuroscience accessible to almost everyone. So they created this Arduino plug-in module that enables you to experiment with your brain and your muscles, or your friend's muscles. So you can control your friend's muscles with your brain. They also have hopes of curing things like muscle twitches caused by Parkinson's disease with a sort of noise cancellation for muscles. Now, I've talked a lot about both 3D printing and open source electronics, but what about when the two come together? Imagine what the possibilities are. But you don't have to imagine that. This guy, Nico, he had his hand amputated. But because he couldn't afford the existing prosthetics and they weren't that functional, he created his own prosthetic arm and hand using open source electronics and also the power of 3D printing to make a hand that fit him well and did everything he needed. He calls it the Bionica. It's sort of like the $6 million man, but less expensive. I'd like to thank you for your time, and I have a lot more I could talk about, but that's all I have time for. You can come talk to me over here if you have any other questions. Thank you.
Yeah, I know, really? That's incredible. Thank you, Schuyler. Yeah, come up and ask some questions you might have for Schuyler here. He's got the answers, and he's willing to 3D you a latte if you need one in that little machine, so come on up.